We have seen how computers work at the low level. They are built of switches. Usually today they are transistors. The switches the transistors are grouped to form logical gates, and the gates are compounded to form logical units. So this is a higher level of abstraction, and we are going to see what are the logical units of modern computers. Almost all the computers use the von Neumann's architecture. And to understand what's von Neumann's architecture and what are the logical units of a computer, let's take some historical perspective, and I'm gonna show you how the first computer worked. This is the ENIAC. It's the first all-purpose, general-purpose computer. So how did it work? Well, remember that in a computer, okay, let's move this a little bit so we can see the programmer. A computer has some inputs and it generates some outputs. In this case, it didn't have a screen or something like that. It was mostly done by paper and everything like that, punched cards and that kind of inputs and outputs. But anyway, we need something here. This is the computer that processes inputs and generates outputs. So the computer had two parts. Well, so had a lot of parts. You can see this was very big, but it had some working memory. It had memory to store intermediate results. So the computer were able to remember, for example, the result of a computation when doing another. This is the computation. And it had, in another place, it had the program. This is what tells the computer what it must do with the inputs. And the program was this part of here, I think, this part. So in case you wanted to reprogram the computer, to reprogram the ENIAC to do a different thing, you usually needed to change cables from one place to another, maybe store some information here in some place with a memory. You need you almost need to rebuild all the internal structure of the computer. And then it uses the memory and it produces the output. So it's something like if you have imagine this circuit. Okay, you have this. I know I'm just making it up. And for programming it, you just change this cable from here to here. Okay, that was the way of programming the computer. But the most important part is this, that the program was separated from the memory. So we have in one place, you had the program, and in other place, you had the memory of the computer. But in this program, the internal structure of ENIAC was a little bit of a chaos. It had a lot of circuits just for adding, for example. And when improving the ENIAC, they rebuilt entirely. They made a completely different structure when rebuilding it. So from the ENIAC, they wanted to do the EDIBAC. It was the computer that will substitute the ENIAC. Sorry, I need an A here. To the ENIAC, from the ENIAC to the EDIBAC, von Neumann published an architecture. Von Neumann published a new kind of architecture to build EDIBAC in a completely different way. So this is what is called a program controlled computer because it's controlled by a program. But what Von Neumann uh, proposed was something completely different. What they wanted to do is this, what we call the von Neumann's architecture. I have a picture here. It will be easier if I put it here. Okay, this will be the new architecture for the EDIBAC. It was not the first computer built with that architecture, but it was designed for that computer, and it changed completely the internal structure of the computer. So uh, what what, what he proposed, but was to have here a central processing unit. It was the same central processing unit for whatever program you needed to run. The central process unit was composed of a control unit, uh, an arithmetic logic unit, and some registers. This part was uh, was the one that made compute arithmetic and logic operation. As for example, it was if you needed to add two numbers, you needed to pass those numbers to the arithmetic logic unit. If you wanted to do, I don't know, an XOR of two numbers, you need to make that numbers accessible here. That's the arithmetic logic unit. The control unit was designed to just control how everything worked. We will talk more. We will talk more about it later. And you have here some registers. The registers are temporary memory, very very quick, just to help for some operations. For example, this told what was the next instruction to run. And the most important part here is that you don't have a separate program anywhere. So you don't have, remember in the previous architecture, you have the programming in one way and you had the memory here separated. In von Neumann's architecture, you have the program here inside the memory. This is the program. So if you need to run something, you first need to load your program here to the memory, and then the control unit will read the instructions of the program and will execute them using some set of previous rules defined by the computer. So that's the difference. That's what that's that is called the stored control computer, stored program computer, because the program is not separated in a different way, but is inside the memory, and you have here the program stored in the computer. And that's how computers, almost all computers works today. The program. There are some computers. This is called the hardware architecture. No, hardware. No, sorry, I think it's hardware architecture. It's still used in some components, in some new PVC computers. Maybe we will talk a little bit about them later. But the main part is that we have here the program inside the main memory of the computer, and we have a general purpose central processing unit that reads the program from memory and executes it. That's how computers work today.